Welcome to our comprehensive guide on Selenium, the leading tool for web application automation. In this video, we'll walk you through the most frequently asked questions about Selenium, helping you prepare for interviews or deepen your understanding of this powerful suite. Whether you're a beginner or an experienced QA engineer, these insights will clarify key concepts, features, and best practices. Let's start by understanding what Selenium is and why it's so widely used in the world of test automation. Selenium is a robust test automation suite designed specifically for automating web-based applications. It supports a wide range of browsers, programming languages, and platforms, making it a versatile choice for testers and developers alike. With Selenium, you can automate repetitive tasks, validate web functionality, and ensure your applications work seamlessly across different environments. Its open-source nature and active community make it a go-to tool for anyone involved in quality assurance. Selenium comes in four main forms, each serving a unique purpose. Selenium WebDriver is the most popular, allowing you to automate web applications using native browser methods. Selenium IDE is a Firefox plugin that operates on a record-and-playback principle, making it accessible for beginners. Selenium RC, now deprecated, uses JavaScript for automation. Finally, Selenium Grid enables parallel test execution across multiple machines, boosting efficiency for large-scale projects. Selenium offers several compelling advantages. It's open source and free, eliminating licensing costs. The tool supports multiple programming languages, such as Java, Ruby, and Python, and allows for multi-browser testing. Selenium's active community and wealth of online resources make troubleshooting and learning easier. Non-programmers can use Selenium IDE to write scripts, and Selenium Grid enables distributed testing on remote machines, making it a flexible solution for teams of all sizes. Despite its strengths, Selenium has some limitations. It cannot test desktop applications or web services directly. Creating robust scripts with Selenium WebDriver requires programming knowledge, which can be a barrier for some users. Additionally, Selenium often relies on external libraries and tools for tasks like logging, testing frameworks, and reading external files. Understanding these limitations helps you plan your automation strategy more effectively. Selenium WebDriver supports a variety of browsers, making cross-browser testing straightforward. Commonly used browsers include Google Chrome with ChromeDriver, Firefox with FireFoxDriver, Internet Explorer with InternetExplorerDriver, and Safari with SafariDriver. For headless testing, HtmlUnitDriver is available. Selenium also supports mobile automation through Selendroid and Appium for Android and iOS platforms, ensuring broad compatibility for your testing needs. A common question is whether Selenium WebDriver can be used to test APIs or web services. The answer is no. Selenium WebDriver automates web applications using browser-native methods, while web services are typically headless and do not have a user interface. For API testing, other tools like Postman or Rest Assured are more appropriate. Understanding this distinction helps you choose the right tool for each testing scenario. Selenium WebDriver is primarily used for automated functional and regression testing. Functional testing ensures that each feature of your web application works as intended, while regression testing checks that new changes haven't broken existing functionality. By automating these tests, you can quickly identify issues and maintain high software quality throughout the development lifecycle. Selenium provides several ways to locate elements on a web page. These include using the element's ID, XPath, CSS selector, class name, tag name, name, link text, and partial link text. Mastering these locators is essential for writing effective automation scripts, as they allow you to interact with different parts of your web application reliably and efficiently. XPath or XML path is a query language used for selecting nodes from XML documents. In Selenium, XPath is a powerful locator that helps you find elements based on their structure and attributes. By mastering XPath, you can create flexible and precise selectors, making your automation scripts more robust and adaptable to changes in the web application. Absolute XPath locates an element by starting from the root node of the HTML document, typically the HTML tag. While this method is straightforward, it's also fragile. Any change in the UI structure can break the XPath. For example, an absolute XPath might look like HTML/body/div/div2/div/div/div1/div/input. Because of its sensitivity to UI changes, absolute XPath is generally not recommended for dynamic web applications. Relative XPath allows you to locate elements starting from anywhere in the HTML document, not just the root. This makes it more flexible and robust, especially when dealing with dynamic web pages. For example, //input ID equals username is a relative XPath that finds an input element with a specific ID. Relative XPaths are less likely to break with minor UI changes, making them the preferred choice for most automation tasks. In XPath, a single // is used for creating absolute XPaths that start from the root node, while a double / is used for relative XPaths that can start from anywhere in the document. Understanding this distinction helps you write more effective and maintainable locators, ensuring your automation scripts remain stable even as the web application evolves. Relative XPath is generally preferred over absolute XPath for most automation scenarios. This is because relative XPath can still identify elements even if some UI changes occur, whereas absolute XPath often fails with even minor modifications. By using relative XPath, you make your test scripts more resilient and easier to maintain over time. The key difference between absolute and relative XPath is how they traverse the HTML document. Absolute XPath starts from the root node and follows the entire path, while relative XPath jumps directly to the node based on specified attributes. This makes relative XPath more adaptable and less prone to breaking when the UI changes, which is crucial for maintaining reliable automation scripts. Use different locators effectively. You need to inspect web element attributes. Tools like Croppath or browser developer tools make this process straightforward. Croppath is a plugin that provides XPath and CSS selectors, while the browser's built-in inspector lets you write, click, and examine elements directly. By understanding attributes like id, class, and name, you can craft precise locators for your automation scripts. Sometimes you need to locate elements whose attribute values are dynamic but contain a constant part. In such cases, the contains method in XPath is invaluable. For example, // contains at name user will match any element whose name attribute includes the word user. This approach is especially useful for handling elements with changing IDs or classes. XPath also allows you to locate elements based on their visible text using the text method. This is particularly helpful when you want to interact with buttons, links, or labels that have unique text values. By leveraging text-based locators, you can make your automation scripts more intuitive and easier to understand. To navigate to the nth child element using XPath, you can use square brackets with an index or the position function. For example, div2 selects the second div element, while div position equals 3 selects the third. These techniques are essential when dealing with lists or tables where you need to interact with specific items based on their order. CSS selectors offer another powerful way to locate elements. To find elements by class, use the class name syntax. For example, InputText selects all elements with the class InputText. This method is concise and efficient, especially when dealing with multiple elements sharing the same class. To locate elements by their ID using CSS selector, use the idValue syntax. For example, #u0n selects the element with the ID u0n. Since IDs are unique within a page, this method is highly reliable for pinpointing specific elements quickly and accurately. CSS selectors also allow you to select elements based on attribute values using the attribute equals value syntax. For instance, type equals radio selects all elements with the attribute type set to radio. This method is especially useful when you need to interact with form elements or filter elements based on specific attributes. The fundamental difference between XPath and CSS selector lies in their navigation capabilities. XPath can traverse both up and down the document tree, allowing you to move to parent elements. In contrast, CSS selector can only move downwards, from parent to child. This distinction is important when choosing the right locator for complex web structures. To launch different browsers in Selenium WebDriver, you create an instance of the driver for the specific browser you want to automate. For example, to launch Chrome, you use ChromeDriver. For Firefox, FireFoxDriver. This flexibility allows you to test your web applications across multiple browsers, ensuring compatibility and a consistent user experience. Selenium provides two commands for navigating to a URL: driver get URL and driver navigate to URL. Both commands achieve the same result, taking you to the specified web address. There is no functional difference between them, so you can use either based on your coding preference. Type text into a text box using Selenium. First, locate the element using a suitable locator such as by ID search. Then use the send keys method to input your desired text. For example, search text box, send keys. Search term will enter search term into the identified text box. This method is essential for automating form submissions and search functionality. Selenium is a popular topic in QA and automation interviews. Understanding its core concepts, strengths, and limitations can give you a significant edge. Interviewers often focus on practical knowledge, such as writing locators, handling dynamic elements, and explaining the differences between XPath and CSS selectors. Being well-versed in these areas demonstrates your readiness for real-world automation challenges. Selenium WebDriver is the core component of the Selenium suite, enabling direct communication with browsers. It uses browser-native methods to automate tasks, providing a realistic user experience during testing. WebDriver supports multiple browsers and programming languages, making it a versatile tool for automation engineers. Selenium IDE is a user-friendly Firefox plugin that allows you to record and playback test scripts without writing any code. It's ideal for beginners or those who want to quickly automate simple tasks. While it's not as powerful as WebDriver, Selenium IDE provides a gentle introduction to automation concepts and helps users get started with minimal setup. Selenium Grid enables you to run tests in parallel across multiple machines and browsers. This distributed approach significantly reduces test execution time and allows you to validate your application in different environments simultaneously. Selenium Grid is especially useful for large projects with extensive test suites. Selenium Remote Control, or Selenium RC, was an earlier component of the Selenium suite that used JavaScript to automate web applications. However, it has been officially deprecated in favor of Selenium WebDriver, which offers more robust and efficient automation capabilities. Today, most projects rely on WebDriver for their automation needs. One of Selenium's greatest strengths is its active and supportive community. There are countless tutorials, forums, and documentation available online, making it easy to find help and stay updated with the latest best practices. Whether you're troubleshooting an issue or learning a new feature, the Selenium community is a valuable resource. Selenium supports a wide range of programming languages, including Java, Python, Ruby, and more. This flexibility allows teams to integrate Selenium into their existing tech stacks and leverage their preferred languages for automation. Choosing the right language can also help streamline collaboration and maintenance. With Selenium, you can perform multi-browser testing to ensure your web application works consistently across different browsers. This capability is essential for delivering a seamless user experience, as users may access your application from Chrome, Firefox, Safari, or Internet Explorer. Selenium's browser drivers make this process straightforward and efficient. Selenium Grid allows you to distribute your tests across multiple machines and environments. This not only speeds up test execution, but also helps you identify environment-specific issues early. By leveraging Grid, teams can maximize their testing efficiency and coverage. Selenium often works in conjunction with external tools and libraries. For example, you might use Log4j for logging, TestNG, or JUnit as testing frameworks, and Apache Poi for reading Excel files. Integrating these tools enhances Selenium's capabilities and allows you to build more comprehensive automation solutions. Selenium supports headless browser testing using drivers like HtmlUnitDriver. Headless browsers run without a graphical user interface, making them ideal for automated testing in CI/CD pipelines or environments where resources are limited. This approach speeds up test execution and reduces overhead. Selenium extends its automation capabilities to mobile platforms through tools like Selendroid and Appium. These tools allow you to automate Android and iOS applications, ensuring your web and mobile apps deliver a consistent experience. Mobile automation is increasingly important as more users access applications from their smartphones and tablets. Selenium is widely used for functional and regression testing. Functional testing verifies that each feature works as intended, while regression testing ensures that new changes don't break existing functionality. Automating these tests with Selenium helps maintain high software quality and speeds up the release cycle. Let's recap the main locators available in Selenium: ID, XPath, CSS selector, class name, tag name, name, link text, and partial link text. Each locator has its strengths and is suitable for different scenarios. Mastering these will make your automation scripts more reliable and easier to maintain. Web applications often have dynamic elements whose attributes change over time. Selenium provides methods like contains and starts with in XPath to handle such cases. By using these techniques, you can create robust locators that adapt to changes, ensuring your tests remain stable. To get the most out of Selenium, follow best practices such as using relative locators, keeping your scripts modular and integrating with CI/CD pipelines. Regularly update your dependencies and leverage the community for support. These practices help you build scalable, maintainable, and reliable automation frameworks. Some common pitfalls in Selenium automation include relying too heavily on absolute XPath, neglecting to handle dynamic elements, and not using weights effectively. Avoiding these mistakes will make your tests more robust and less prone to failure as your application evolves. In real-world projects, Selenium is often integrated with other tools like Jenkins for continuous integration, Git for version control, and reporting frameworks for test results. This ecosystem enables teams to automate their testing processes, catch bugs early, and deliver high-quality software efficiently. To wrap up, Selenium is a powerful and flexible tool for automating web application testing. By understanding its components, locators, and best practices, you can build effective automation frameworks and excel in interviews. Continue exploring Selenium's features, practice writing scripts, and stay engaged with the community to keep your skills sharp.